Okay, so now we're going to do section 9.1 and do the second part of it. So it's part two of the 9.1 video lesson series, if you so desire, inclined to say. And so what I'm going to do is I'm going to share the notes that we actually started last time and go ahead and find this page. It's about halfway through, maybe a little more than halfway through the section. And what we're going to do, if you remember, we kind of finished up last lesson or last part of this lesson in the first video, talking about how to rationalize the denominator, right? Because you're not allowed to have a radical in the denominator according to simple rad form. But every time we did, we had a monomial. We had one term, right? We had one term. And what we're going to do now is we're going to see, well, what do we do when there's two terms? Okay, and this is going to remind you of when we learned how to multiply out what we call conjugate binomials. Okay, so remember, conjugate binomials are when the first term's the same and the second term's opposite. So remember, like x plus 3, then x minus 3. And what we saw when we multiplied those is that we didn't get a three-term, we didn't get a trinomial, three terms. Remember the outside and the inside, if we FOILed, canceled out. Well, in fact, I can show you that. Remember how we FOILed here? Difference two squares, remember? So a squared, negative ab, positive ab, those would cancel out, and then minus b squared. We're going to be using that, okay? So you can use conjugates to simplify radicals when they're in this form, like two terms, like binomials, 2 minus root 3, okay? What you want to do is multiply by the conjugate binomial. So you would multiply it by 2 plus root 3. And then again, whatever you do the denominator, you got to multiply it to the numerator. We're not trying to change the value of the original problem. Remember, the original problem was that, right? You're trying to change the way it looks. You're trying to simplify it. It's like saying if I said simplify 50 over 100, you change it to 1/2. Okay, so what happens when we multiply this 7 times this binomial? You actually have to distribute this, because this is a monomial times a binomial. So the 7 gets multiplied by the 2, and it also gets multiplied to the root 3. So we get 14 plus 7 root 3. Now, when we multiply it by a binomial, we FOIL, right? So watch what happens. 2 times 2 makes 4. Outside gets us positive 2 root 3. When we multiply 2 times negative root 3 on the insides, that gets us negative 2 root 3. Well, those cancel out, right? And then all we're left with is negative times the square root of 3, or negative root 3 times root 3, which is minus 3. 4 minus 3 is 1, so we can simplify that. Remember, fraction sign is grouping symbol. Here we can't add the 14 and the 7 because this is the 7's being multiplied times the root 3. We have to do that first according to order of operations, but we can't because we don't know exactly what root 3 is. So this becomes a denominator of 1, which means we don't need to write it. Okay. Here's another example of multiplying conjugate binomials when you have radicals involved. So if I wanted to multiply 2 root 5 plus 3 times its conjugate, that would be multiplying by 2 root 5 minus 3. First terms, 2 root 5 times 2 root 5. 2 times 2 makes a 4. Root 5 times root 5 makes 5. 4 times 5 is 20. Okay. Outside would be negative 6 root 5. Inside would be positive 6 root 5. Those are going to cancel, right? Like we've always seen when we multiply conjugate binomials. And then 3 times negative 3 is like minus 3 squared, or minus 9. That's 11. No more radicals. No more radicals. Okay. Here, no more radicals in the denominator, which is what we care about. Okay. So again, just remember how we FOIL. Important here. Same thing. So we can get conjugate binomials. Okay. And we already went through this example. Here's another one, right? 2x plus 9y, 2x minus 9y is going to multiply out and get you that. Okay. All right. So we already did these the other day. So let's do these three problems. Okay. So is there anything we can simplify first before we move on? No, eight's, no, can't do that. Root 3, no. Okay, so what are we going to multiply top and bottom by? The conjugate of 1 plus root 3, which is 1 minus root 3. Again, got to be the top and bottom. Distribute up top. So I get 8 times 8, or negative root 3. 8 times negative root 3 is negative 8 root 3. Okay. Conjugate binomial, so we know it's going to end up being the first term squared, which is 1, minus the second term squared. What's root 3 times root 3? Yeah, it's 3, so it's 1 minus 3. Now watch what happens when I'm going to simplify, right? The denominator, and I get a negative 2. Now let me ask you this. How many terms do we have in that fraction? Hopefully you said 3, because we have 8. Remember, terms are things that are added and subtracted, or that just stand alone. So 8 is a term, negative 8 root 3 is a term, and negative 2 is a term. Okay. Do they all have a common factor that we can reduce by? And the answer is yes, right? We could reduce them by 2. So basically the 8 becomes a 4, the negative 8 becomes a negative 4, and the negative 2 becomes a negative 1. Okay. Now, we usually don't just leave like a negative 1 in the denominator. So I could move it up top, right? And I want it to go to everything. So it would end up being what? It would end up being distributed. So we end up getting negative 4 plus 4 root 3. Okay, try this next one here. What do you think you're going to need to do? Okay, hopefully you said multiply by the conjugate binomial, because there's nothing we can do with square root of 13, right? Square root of 13 is not a perfect square factor, right? So leave that. Distribute the numerators. 13 times 5, 65, and then plus root 13 times 2 is 2 root 13. Conjugate binomials in the denominator, so it's going to end up being the first term squared minus the second term squared. Now watch this one carefully, because square root of 5 times square root of 5 is equal to what? 5. But 2 times 2 is 4. So just remember, one's under a radical and the other one's not. Okay. 5 minus 4 is 1. So our simplest answer is square root of 65 plus 2 root 13. Is there, I know there's radicals there, but do they have any perfect square factors in them? Do 4, 9, 16, 25, 36, so forth, do those go into 65 and 13? No. And there's no radical in the denominator, so we're good to go. Okay, check out the next one. 12 over root 2 plus root 7. Is there anything we can do to simplify any of those? No. And remember, you can't just cross out the 12 and the 2, because one's under a radical sign and one's an outie. And all three terms would have to have a common factor, like we saw over here with the 8, the negative 8, and negative 2. Okay, so what are we going to multiply top and bottom by? The conjugate binomial, right? Okay. Distribute up top. 12 times root 2 is 12 root 2. 12 times negative root 7 is negative 12 root 7. FOIL, or realize it's conjugate binomial, so it's going to end up being first term squared minus the second term squared. And then 2 minus 7 is negative 5. Again, we don't like to have a negative, so we can either move that to the middle or distribute it up top. Here I put it in the middle. Let me move this out of the way so you can see what I'm talking about. Okay. Again, simplest form means no negative constant alone in a denominator. All right. Great, we did this problem with Ms. Dickinson looking at the lighthouse and out to sea. So here's another one. Let's try this word problem. The ratio of the length of the width to the width of a golden rectangle is 1 plus root 5 to 2. The colon means ratio. The dimensions of the face of the Pantheon in Greece form a golden rectangle. Okay. What's the height h of the Parthenon? Okay. So we know that this length and this height form this ratio, right? So what we can do is what? What do you think you would do? hopefully you said you could form a proportion, right? We know that 1 plus root 5 over 2, ratio means a fraction, is equal to this length over this height. So this is the length, that's height, length, height. Okay. Now, what would we do here in order to solve for h? Okay. Well, one thing you could do is cross multiply, right? So we can multiply 1 plus root 5 times h, which means we'd have to distribute the h to the 1 plus root 5. And then we can multiply the 2 times the 31. So we can do cross products. Now we no longer have a fraction. And in order to get h by itself, we need to divide by this factor of 1 plus root 5, right? So we'd have 62 divided by 1 plus root 5. Okay. All right, well, I can't leave our answer like that, right? There's a radical in the denominator. So we have to multiply by the conjugate binomial, distribute up top. 62 times 1 is 62. 62 times negative root 5 is negative 62 root 5. Conjugate binomials in the denominator, right? So we know that's just going to be the first term squared minus the last term squared. So that's just 1 minus 5. Careful here. 1 minus 5 is negative 4. All of these terms have a common factor. Oh, notice how with the negative 4, I moved the negative to the middle. Totally fine to do that. 2 goes in all these, doesn't it? So I can reduce them by a factor of 2. Now, granted, this is a word problem, so we're not going to leave our answer like this. Someone would think you're crazy if you said the answer is that. Just like, how tall is it? It's negative 31, minus 31 root 5 over 2. So you would want to write it like that. Okay. All right. And yeah, that does make sense because 1 plus root 5 is bigger, right? Just like 31 is bigger than 19.16. Okay. All right. So let's do another one similar to that, and then we'll do the top one. So the dimensions of a dance floor form a golden rectangle. The shorter side of the dance floor is 50 feet. What's the length of the longer side? So think about how you'd want to set that up. There's the golden rule, right? Right there, ratio. So hopefully you said like that. And we need to solve for L, right? So cross products again. This is very similar to the other ones, just different numbers. And then we would divide by 2. Well, doesn't 2 go into 50 and 50? So you could write this as 25 plus 25 root 5 over 1, or just 25 plus 25 root 5. And then you get your calculator out. You figure out it's about 81 feet. Okay. Remember here we were talking about how high your eye level is. So 35 would go in for H, right? So 3 times 35 is 105. What would we do next? Can't have a fraction in a radical, right? It's not simple rad form. So we would split it, right? And then what would you multiply top and bottom by? Root 2 over root 2. Then we can finally write it. But since it's a word problem, we're going to figure out what the square root of 210 is, and then divide by 2, and it's about 7.25. All right. Now, performing operations with radicals. Okay. So here we're going to be dealing not with just like one thing, right? Where we're basically just starting with 1 over root 5, one fraction. But now we're going to involve, or one term, we're going to involve numerous terms, okay? And remember, you still want to follow order of operations. So like if there's something that you can simplify, like the square root of 20, like we can do that, right? We know that that's going to be root 4 root 5 or 2 root 5. You want to simplify each term first and then look for what I like to call like terms still. Here's an example of that, okay? In this problem, 5 root 7 plus root 11 minus 8 root 7. We don't know exactly what root 7 is, right? We don't know what the square root of 11 is. So you can almost think of those as like variables. So I would almost say, think of this as like 5x plus y minus 8x. Well, if that was the case, wouldn't you take that 5x and the negative 8x and combine them together? Same thing with this, okay? So watch how this happens. So first of all, can I do anything to simplify 5 root 7 by itself? No. What about square root of 11? No, no perfect square factor is that. And negative 8 root 7, no, we can't. Okay. But we do have two like terms, right? So another way of thinking of this is we could say, oh yeah, that's like 5x. This is like negative 8x, right? We always take the sign with it. And we can combine those to make negative 3 root 7. Okay. And then this plus 11 just gets added on, okay, because it's not a like term. Okay. All right. All right, so, and again, this is a good study tip over here. Do not assume that radicals with different radicands, where radicand's a number under the radical sign, cannot be added or subtracted. Always check to see whether you can simplify the radicals. In other words, do what I'm saying. Simplify, look to see if you can simplify any of the terms first by taking out perfect square factors or whatever, and then look to combine, okay? So if you look here, 10 root 5 plus root 20, you won't want to say, oh, there's nothing I can do with this. It's in simple form. No. Square root of 20, you can simplify, right? That's the same thing as square root of 4 times square root of 5, which is 2 root 5. So you can see the 2 root 5 down here, right? So now all of a sudden we have 10 root 5 plus 2 root 5. Well, don't those have the same quote unquote variables, the same unknown radical, square root of 5? We have 10 of them. If you add 2 of them to it, you've got 12 of them. So 12 root 5. And then here you can see 6 times the cube root of x plus 2 times the cube root of x. Do you know what the cube root of x is? No, of course you don't. You don't know what x is. How would you know what the cube root of x is? But if you have 6 of them and Johnny over there's got 2 of them, to put them to your collections together, you got 8 of them, or 8 cube root of x. Okay. So this is an interesting problem. I really like this problem because if you look at this, you might say, oh, I'm going to distribute the root 5 to them. And you could do it that way. But also look inside the radical. Can you do anything inside the parentheses? Excuse me. Can you do anything with the square root of 3? No. But what about the square root of 75? Yeah. You can make that the square root of 25 times the square root of 3, right? And what's the square root of 25? 5. So now inside the radical, you have root 3 minus 5 root 3. Well, aren't these like terms? Isn't this the same unknown radical as in this term? So we had a positive 1 of them and a negative 5 of them. Doesn't that mean we have a negative 4 of them, or negative 4 root 3? And so now this is just a root 5 times minus 4 root 3, which gets us negative 4 root 15. Okay. So try some of these, okay? 3 root 2 minus root 6 plus 10 root 2. Can we simplify any of those terms individually? No. Okay, do we have any like terms? Yes, this one and this one, right? If I have 3 of something and I add 10 of that same something to it, how many of the somethings do I have? 13 of them, right? So notice how they write them together, and then so they're changing the order using the commutative property, and then we get 13 root 2 minus root 6. Okay. All right, what about 4 root 7? Can we simplify that term by itself at all? No, square root of 7, there's nothing to do. What about square root of 63? Oh, 9 times 7. Yes, we can, right? So what's the square root of 9? It's 3. So now it's an outie times this negative 6 makes negative 18 root 7. Do we have like terms? Yes, we do. This is like 4x minus 18x, right? If you have 4 of something and you subtract or combine it with negative 18 of that same something, you have negative 14 of that same something, or negative 14 root 7. Okay, try the next one. Look at it carefully. Can't simplify any of the terms, right? We can't take the cube root of 5x. But if you have 4 of them and negative 11 of them, how many do you end up with? Negative 7 cube root of 5x. All right, this one down here, we've got this 2 terms, binomial, right? And we've got it squared. So we're going to use our shortcut for multiplying out, right? What's the first term squared? What's 2 root 5 times 2 root 5? The 2's multiply to get you an outie of 4. The root 5 times root 5 makes 5. So we end up getting, well, we're going to do this, right? Let's look at this first. First, we square the first term, double. That's why we have the 2, the product of the 2 terms, right? And then we square the last term. So 2 root 5 times 2 root 5 becomes 4 times root 25, or 4 times 5, which is 20. All of this becomes -2 times -4, which is 8. I'm missing a negative sign there. What am I doing here? Oh, I have an extra negative sign, don't I? Yeah, this should just be -2 times -4 times 2 root 5. So yeah, this should become a negative roots 5. See, if I multiply that negative times that negative, I get a positive. So yeah, it should be there. And then last term squared, -4 times -4 is positive 16. Okay. Can I combine any like terms here? Yep, constants, 20 and 16 makes 36 minus 16 root 5. And I know you want to combine that 36 and minus 16, but remember that 16 to the -16 is connected to the root 5. Can't do that. All right. Inside the parentheses, let's see if we can simplify anything. 8 root 2. Can you do anything with that? No. Square root of 32, though. Perfect square factor of 16, doesn't it? Okay, so what's the square root of 16? It's 4. So now I would have 7 times 4, which are 2 outies. I can multiply those and make 28. So I have 28 root 2. Well, before I distribute this root 3, don't I have like terms inside the parentheses? Isn't 8 root 2 and 28 root 2 something we can combine? What would you get when you do that? If I said 8x plus 28x, wouldn't you say 36x? So this is 36 root 2. And then I need to multiply by that by the root 3 to fully simplify it. And I get 36 root 6. Remember, we can multiply innies with innies. Okay. All right. Then on this last one, anything we can do to simplify this? Cube root of -4. No. Cube root of 2. No. Cube root of 16. Oh, yeah. I know 8. Cube root of 8 is a factor of that, right? So now I could simplify this negative cube root of 8, and that becomes a -2, right? So I get -2 times cube root of 2. Are these like terms now? Yep, same number under the radical. So if I have 1 cube root of 2 minus 2 cube root of 2, that's -1 cube root of 2, or negative cube root of 2. Okay. Then I can multiply the innies together, right? If I do that, I get -4 times 2 is -8. Negative outie can stay out there, right? What's the cube root of -8? -2. But then we still have that negative that's outside, don't we? So we end up getting 2. All right. This was a very long lesson. Glad we split it into 2 parts. And I think that is the end of it. So let me stop the share. And congratulations, you're done with all the radical stuff. A lot in there. We're going to take some time to digest it. And then that'll serve you well through the rest of the unit. All right, cool.